Hi everyone. Today we're going to build this mouse trailing particle effect. This effect is basically a way of us taking a single point and adding multiple points into a system. So essentially we have a point that can respawn itself. So kind of creating our own very basic sort of particle system component. And what happens is as we draw, these particles will move around our mouse and then they'll disperse and eventually disappear. This is an effect that is to a small extent inspired by this noise turbulence doodle by Raven Kwok. And basically what we have here is we can see the biggest particles are attached to my mouse, and then we have these particles that sort of splay out that follow this sort of noise vector. This is an open processing sketch, and as you can see, it kind of spawned lots of different iterations from various people. I quite like this one where it spawns these lines. And what's kind of interesting about these types of tools is we can see how simple changes make really interesting visual representations in how they change. So this is kind of something I really like as an effect, and what I really like about generative art. As a little plug, I'd recommend looking at Raven Kwok's work. It's generally really fantastic. So if you can take a look, you probably will get some ideas for your own projects from his body of work. And I believe most of his stuff is built in processing. But more or less, we're going to build the mechanic here to recreate this sort of trailing particle effect, which I really like, and to an extent, even though it doesn't look super similar in the output, is inspired by this basic drawing of the mouse and then these particles moving off using some kind of noise vector. I'm going to close that and I'm going to start a new file. The first thing I'm going to do is add a point. And this point essentially is going to be my first singular point which I'm going to add to. And essentially what I'm going to do is I'm going to put it in a feedback system, not a field system, and add to it every time that feedback loops around. So I'm going to plug it into a feedback. I'm going to plug that feedback into a null. That'll be the end of my chain. And then I'm going to place a merge to essentially just add every time this feedback loop cycles through. So let's take a look at what this is doing right now. So we can see that right now we have 2 points. So this is my initial point and then the merged point, and we haven't done anything to the transform. So we can see that even though we have these multiple particles, they're all centered. Let's see what happens when I plug this into my feedback pop. So we can see our list just keeps growing and growing and growing. And obviously this is something that could get out of hand kind of quickly. So what we also want to do is we want to add an attribute, which we're going to call index. So we've created this attribute called index. It won't have been added to our feedback yet because we have to repulse that. So let's go for a keyboard in, press A to make the viewer active, and then we'll drag that reference over to start. So now, if I press that, we now have index added. And I'll actually just remove this position information. So again, let's see what happens if we play this and go through. So obviously we have this index that's adding this value of 0 to it. So what we need to do is we need to actually add some conditions to allow this to 1, incrementally count, and 2, delete itself after a period of time. So let's go in here after the merge and add in a math. And what's really cool about pops is that we can select any of these attributes that we have created or are statically given to our operators. We can just select that as our scope to work with. So I'm going to set my input attribute scope to index, which is that attribute I just created. We can see here as well that I haven't given index a value other than 0. It's just static. And we can see there it's 0. And so what I want to do in my post add is a value of 1. So now we can see that my index is just going to keep climbing and climbing and climbing, kind of like a ramp. So that's great. We have this index increment now. And what we actually want to do is we want to find a way to create a condition for when we start deleting those particles. And this is where the delete operator comes in. We've looked at the delete operator before in terms of the thin. And so this is where you can basically thin out a bunch of data using either a step size or a random increment. And we actually want to look at this thing called attribute today. And what attribute allows us to do is look at specific attributes and then set up a function. We want to go to this drop down and select this greater than operator. And I'm going to say a value of 100. So now if I reset my system and we look at this index here, we're going to see that it's not going to move beyond 100 points, because every time we add more than 100 points, it's going to delete. I mean, actually, in this case, it's 101. If we actually wanted 100, we could do that, but it's okay. We get an extra index, but it doesn't super matter. So this is basically the system. What we can see is right now we don't really have much going on because we haven't maneuvered those points at all. So I'm going to add in, after my math, a noise pop. And now we can see that that particle is being moved by that noise pop. We could go in and animate that transform, or that translate 4D with abs time dot seconds times 0.1. And then we have essentially a particle trail that's starting from a center point and sort of growing outwards. It's kind of an interesting effect on its own. What we're going to do is we're going to actually render this and then add some mouse control for this. So let's drag this out to a geo. Let's add in a render, a camera. We're going to add in some kind of texture. I think I'm going to select a point sprite for right now. And turn up that scale. And we're also going to add in a out, because I want to view this through a panel, because what we're going to do next is we're going to start working on some user interactivity, that we can actually control this starting position. If you wanted to, you could just add in something like a noise chop and use noise as a way of sort of displacing your point. So let's do just to show you real quick. So I'm going to put my x, y, and z parameter into a transform, which is going to move my point. So I'll create a transform right here. And for the translate x, the translate y, and the translate z, my point is now going to be moving. If I turn this down a little bit, actually I want to turn down the amplitude. Here we go. We can see that my particle is moving and it's kind of shooting off all these noise-based particle trails, which is sort of an interesting effect. But what we're going to do here is we're going to replace this with a mouse movement. So I'm going to put in a panel chop. I'm going to drag this out to a select, and I'm going to select inside U and inside V. I'll view this. Actually, I'm going to plug this into a null because there's going to be some more stuff we're going to do. And you know what? I'll label this mouse pos. I'm going to make that viewer active and view it. And I'm going to drag this into my transform. That's great. And I'm going to remove my Z. So we can see that now it is responding to my mouse movement, but we're having some issues here where it's not really showing us something that really aligns to the mouse, which can be a bit annoying. So I'm going to add in a couple things here that are going to make it much more aligned and actually snap to the mouse. So I'm going to add in a math. We can see here that our coordinate system is a little bit off, so we're moving no further than this quadrant of the screen. We're not going fully across the screen, so we know that our positions are normalized between 0 and 1. So what I want to do in my range is go from 0 to 1 to minus 0.5 to 0.5. So this is the first step. And now this is going to output something that's going to center our values around a central position, but we can still see when I go really far out, we're not actually seeing that movement match the mouse. And this is something I'm going to fix in my camera settings. So in camera, I'm going to go to view. I'm going to set the projection to orthographic, and I'm going to set my ortho width to 1. So now we can see that this is actually matching the mouse. It's a bit challenging because obviously we can see that things are moving away over time. But what I'll do to just visualize that for you to see is I'm also going to add in just a larger circle, which I'll merge in at the end. And I'll copy this transform just so we can see that circle maneuver exactly on my mouse coordinate. It's also really big, so let's turn down that radius to a much smaller value. There we go. We don't need to continue to see that, so I'll delete that. But we get the idea. We have now this version of our particle system that essentially follows the mouse and spawns these particles. What we also might want to do is we might want to create some kind of scale factor. So we might want to have the particle system control how big these circles are. And there's a couple of ways to do this. The way I really like to do this is to use a copy pop. What I can do here is I can take a circle, I'm going to plug it into a copy, and I'm going to plug the second inlet of my copy into these positions. And now we can see that this is somewhat moving to my positions, although these circles are very, very large. I'll plug this in so this is what we actually see. So we can see we've got some movement here. What I'm going to do is I'm actually going to apply my age value to these circle positions. First off, I'm going to make my radius real small. So we can see we're back to these little points again. I'm going to go back to my copy pop, and I'm going to go to template. In template, we have this handy tab for things that we can apply to our copied network. So in this case, I could copy my scale, and I could copy it based on index. So we can see that as we move further away from our desired point, our index is getting bigger. So as that life increases, we are moving to these larger circle particles. What I might actually want to do is go in create a math. I'm going to go to my index. I'm also going to set an attribute scope of scale. And what I'm going to do in my math here is I know that my index goes from 0 to 100. And what I can actually do to make this sort of link and be a bit more dynamic is I can bring this value to my high value here. So if I change this value to like 50, it's automatically going to update in this map from high, or if I change it to something much higher. And what I want to do is I just want to scale this to a different value, and I basically want to invert it. So I want my low value to be 1 and my high value to be 0. So now let's see if I apply this to my copy. What we'll see is, because I have ranged back down, remember how my highest value before was 50, the scale is going to be quite small, and that's because I've ranged this circle down quite a bit. So let's go back, make the circle a little bit bigger. There we go. Maybe even 0.05. But now we can see that we have a trail that, as we move away from it, gets smaller. And this is a super nice effect. To sort of zhuzh this up a bit, I can play with my noise. So I'll turn that amplitude up to 1, or actually 0.5, 0.05 even. And this will be a bit faster too. And I'm going to turn my period down, so it's going to feel more wobbly as we move away. You know, maybe go lower there. Yeah, I like that. So this is one way that we can instance a scale parameter. Another thing we can do is we have this really nice option now in a lot of the textures where we can actually add an attribute. So in this point scale attribute, I could say index. So now whatever my index value is going to apply. You can see how our index is moving from these small particles to these big particles. However, it's kind of square. So in this event, I like this method a lot better. We could also go and now just texture this with something like a constant. You're not limited as well to one type of geometry. You could obviously go in and put in something like a sphere. And of course, make sure you turn it down. There we go. In this case, because it's a constant, we don't have that shading, but if you added in light and shading, you'd have something kind of interesting here. So we've now created this trail that responds to our movement. What I want to do is I want to start creating a couple of these. So what we could do is, rather than have our point that we initially start with, we could have something like this where we have a point generator. I'm going to move this down to like 4. And I'm going to change the radius to like 0.1. And now we can see that we have these multiple particles maneuvering around. If I added in a noise to that and animated the noise, we can see that these particles are moving around on their own volition a little bit. So as I move them around, we have these different outputs. which I think is super cool. What we can do as well to change the color of these points over time is, let's go in and create a new attribute. And we want to create a color attribute. And we'll look this up later. But let's say I want to use a noise to access my colors. Turn on my time slice, and I'll just call this RGB. I'm going to do an offset of 0.5 and an amplitude of 0.5 and turn my period up. So this is going to be my R, my G, and my B. So the color is going to change over time. I now have this color attribute that's being added in. So what I can do in these template attributes is I can turn on update point attributes, and I can select my color. And then we can see over time these colors are going to change. I might want to speed up my period here so the color changes more quickly, and we get this more varied color scale. A final thing I can do after all of this sort of feedback loop and copying is I can put my output into a proximity pop. And then we get this nice sort of trail between these points. I'm going to turn down my maximum distance to like 0.03. But you get this sort of interesting effect as they're close to each other. You also turn up that maximum distance and then have the minimum distance a little higher to create these different types of effects. And that's going a little bit slowly. So what we could do to make that fast is we could go into this delete and select thin, and that's just going to go into the proximity, and then we'll merge these later. And this basically means we're looking at less points to join. I'm also going to go down with both these values. And now that's much faster and more responsive, basically at 60 FPS. So this is the effect. A couple more things that you could do to make it sort of really funky is you could add in a bloom effect in post-production. Let's play with that. Make it a little bit more glowy. Get the intensity right and turn up the radius a little bit. This is really just playing around with values here. I'm then going to plug this into a feedback. I'm going to add a composite, which is going to be also hooked into my render. My mousing isn't going very well today. I've made a couple of mistakes here. So I'm going to actually make sure my bloom is plugged in here, and then I'll plug in my component to my target top. So we'll see that we get this nice overlay. And what I'll then do is add in a level so it doesn't retain. And I'll put that here. The higher it goes, the more of these trails we have. I'm going to add in a keyboard in so we can reset it. And then obviously let's take this level down a little bit. So this is a really fun way of sort of creating these mouse reactive particle chains. A further thing you could do is you could add in something that basically allows you to press. So like we saw in that earlier video, maybe you can have something that only is showing up when you click the mouse. This addition will be in my Patreon files. Anyway, I hope you have enjoyed this tutorial and stay tuned for many, many more. Thank you.